All right, I'm going to tell you a little story about these two kids named Anne and Brian. Anne and Brian were tasked with picking up a big thing. This is the thing they need to pick up. Anne was standing on a box over here, and Brian was standing on a box over here. Anne looked a bit like this. She's quite a striking woman. And Brian, he looked like this. He was pretty attractive himself. They were both very happy. Okay, so here's what they were doing. Here's what Anne's rope was looking like. She had a rope, it was attached to the thing. And Brian had a rope and it was attached to the thing. And they were both pulling really hard, trying to pick up this thing. So the deal was that they had some dimensions, some ways to figure out exactly how this was located. And it turns out that Brian's rope was located 30 degrees at an angle of 30 degrees. And it turned out that Anne's rope was located at an angle of 45 degrees. Just like that. All right. We are going to call Anne's rope A, just because that's a little bit shorter than Anne. And let's call Brian's rope B. And let's put a little arrow up at the top just so that we remember what direction they're pulling in. All right. So here's the deal. Anne and Brian are pulling really hard, but they are not able to lift up the thing. So what we need to do is we need to find this other guy named Ralph. Ralph is very, very big and strong. This is how big and strong he is. He has big muscles, and he is obviously ridiculously big and strong. And Ralph is going to pick up the thing. Ralph is so tall that he doesn't need to stand on these silly little boxes. He just stands straight on the ground. All right, so when Ralph picks up this thing, Ralph will hold on to it right here, and we will no longer need Anne and Brian to pick up this thing. Here's Ralph here. He's super big and strong. He's even got like really kind of a super mean kind of look to him. He's going to show them who's boss, and he's going to pick up this thing. So we're going to call his rope R. We'll put a little arrow up there. Okay, so what we need to do is we need to figure out if Ralph can actually pick up the thing by figuring out how much force is Brian and Anne exerting, so we can figure out how much Ralph will need to hold up. So let's start off with Anne. So Anne is, let's just call this a force vector. Anne's force vector can be broken down into two force vectors. So how much is she pulling in the x direction? How much is she pulling in the y direction? Brian's force vector is also going to be broken down into a bit of x and a bit of y. Then we can add up those two bits and figure out what the resultant force vector, or Ralph's force vector, is going to be. Okay, so over here where Anne is, she's got this bunch of force that she's exerting in the x direction. Let's just call that AX. It almost looks like a T. It's supposed to be an X. She's also pulling up a bit. This here is how much she's pulling up. This is AY. All right, so we have A, which she's pulling up with, and we know how strong Anne is, and we know that she can exert 12.25 pounds. That's what her A is worth. All right, so if she pulls up with 12.25 pounds, how much is that in the X and Y direction? And then what we can do is figure out the same thing for Brian and add up those component vectors and then figure out how much this big resultant vector is going to be, and then figure out how much Ralph needs to pick up. All right, so Anne's vector. Let's see. Let's start with AX. AX, the X component of Anne's vector. If you remember that SOHCAHTOA business, from this angle here, AX is the adjacent side to 45. So the adjacent to 45, if you remember SOHCAHTOA, the cos is adjacent over hypotenuse. So AX over 45, or over the hypotenuse. So we could write that as AX over 12.4 or 0.25 is equal to cos of 45. We can move things around there, solve for AX. I'm not sure if I'm going to survive this all in paint, so let's just move on to setting things up. AY over 12.25 is equal to, so the sine, so SOH, sine is opposite over hypotenuse, so AY over 12.25 equals sine of 45. There we go. All right, we can do exactly the same, but we'll use purple over on Brian's side. We'll say Brian can also have two component vectors. He has BX and he has BY. All right, so his BX is adjacent to the angle. So SOHCAHTOA cos of 30 equals, oh, we didn't even decide what B was. How about we make B 10 pounds? There we go. I might need to get some better drawing software. This is a little bit silly. All right, so cos of 30 degrees is adjacent BX over 10 pounds. That's the hypotenuse. And then, so we've done basically the same thing here. We just wrote it in the other direction. All right, so cos 45 equals AX over 12.25. Cos of 30 is BX over 10. And then sine of 30 there we go, is BY. So is opposite. So BY over 10 pounds, because 10 is the hypotenuse.